So this is, and problem number
10.
10. All right. So can you see the screen?
Yeah,
Is it clear?
it's a little bit blurry.
I'll put all these signs so it would autofocus. How's it now?
It's still a little blurry, but I can see relatively clearly.
No, it has to be normal. All right. Just give me a second. I will. Okay, I will switch from camera to. The screen. So what is your question?
So I'm just a little bit confused on how to solve the problem. I understand how to find, I think, the
Well,
I don't know, I guess I'm just confused.
are you confused? What would unconfuse you? You need to ask a specific
So I
question.
know that I think that C1 and C2 are in parallel,
So
and then
did you use it?
yeah.
How? What did you do?
So I did C1 2 equals C1 plus C2.
Okay, sounds good. And this is C3. And all right. So what did you do next?
And then I did C1 2 3 or 1 over C1 2 3 equals 1 over C1 2 plus 1 over C3.
Yes. So I don't see any issues with that. And what did you do next?
So then I know that the charge is going to be the same for C1 2 and C3 because they're in series. But then I got a little bit confused on how to calculate that.
Well, what did you do? Or you just stopped doing at this point?
So I was thinking of using, because you can calculate using the voltage of the battery and the C1 2 3, you can find the charge.
Well, again, to do that, you have to do something. At least write something. What did you write? What?
I wrote Q equals C delta V.
All right, that is exactly what we need to use. All right, so how did you use it? So far, everything you say sounds absolutely good, natural. So how did you use this equation?
So I used C 1, 2, 3.
C1, so you used it for this.
Yeah.
Okay. So you have your values. So what is your C1
My C1 is 24,
and C2
7,
and voltage?
1.52.
All right. So now we need to check calculations. So Q should be equal to, or first, C12 should be equal to 24 plus 7, right? 31. This is 0.3. So 1, well, we need C123. We have to check it. So it's going to be 1 over 31 plus 1 over 0.3. What is your answer for this?
I got 0.297.
Okay, let me check. What did you, what's your number?
0.297.
All right, so first thing, to keep more digits, just in case.
Okay.
3 digits in general, not enough. 4 digits usually sufficient, but in this situation, since it didn't work for you, you should just keep more digits.
Okay.
All right, this sounds good. So now this is microfarads. So if we use this, so 0.297 times your voltage, 1.52 equals 0.45679.86 kilos. Does it look like your number?
Yeah.
All right. See, I would expect that you didn't have enough digits. Your accuracy wasn't, unless you made a mistake. But at this point, I wouldn't expect that because everything you say makes sense. So this is what I called Q, but it should be the same as Q3, the same as Q12. We're done with that simple circuit. So what was your next step? When you get this charge, what did you do next?
Well, that's where I got confused because I thought that that would be the answer to part A, but then I got it wrong.
Where is it? Part A asks you about charge stored on each capacitor. Well, you didn't find the charge stored on each capacitor. You found only the charge. Where is it? Only the charge on where?
Um,
Where is it? Where did I put it? So this probably is the source of the confusion. What actually did you find?
The charge on Q12 and Q3.
So you found the charge on the equivalent capacitor, this one. But because it was kind of made from this, you are right that these charges have to be the same. But Q12 is not Q1 or Q2. Q12 is only equal to Q3. So this is the answer, but you still don't know Q1 and Q2.
Oh, okay.
So how can you find those? What would you do? You need to look at what you know now, what you did know before, but what you know now. And this is this charge. You didn't know it, but now you know it. So if you know this, it's a new number. Probably you need to ask, how can I use this number now? So how can you use this number?
You can.
There's not many connections, there's not many equations you could use. It's only C1 plus C2 or 1 over or Q equals C delta V. Can you use Newton's second law here?
No.
No. So you have to focus on this or that and ask yourself, if you know charge which you did know, which equation probably you should use now? Which equations?
Q equals C delta V.
So this is your hypothesis, but that's the only hypothesis that makes any sense. So this is your equation. But now you have to use it. To use an equation, you have to choose a system to which you want to apply this equation. So far, you use this equation for this system. You didn't use this equation for other existing systems. So pick one and try to use it. Which would you use?
For the C3.
That's a natural choice, because now you know the charge number 3 and you know the capacitance. So what can you find?
The voltage. Or the
Where?
potential difference.
Where?
For 3.
For only this capacitor number 3. That is exactly correct. So this is how you think it through. All right, now use it. And calculate that voltage or potential difference. And that should be 4, 4, 5, 1, 6, 2, 9, that's -6 divided by 0.3 times 10 to the -6. Should look.
I got 1.505.
You see, Now let me check. 0.45, 9, 1.5 or 543 volts. You see, the issue with accuracy is because this number is very, very close to the voltage given to you.
Mm-hmm.
So if you would just keep a couple of digits, you wouldn't even see any difference.
Mm-hmm.
That's why you need many digits here.
Okay.
But now, if you know this voltage, that's a new number, you know, what can you find? And that should be something about voltage, because we found voltage, so
Well, you can use the 1.52 voltage.
yes. How can you use this 1.52 voltage?
You can find the potential difference by subtracting it from 1.52
Potential difference where?
at 1, 2.
Exactly. So, because if you look at, well, it's not really clear diagram, but okay, we can redraw it quickly. C12, C3. This is the potential difference for one capacitor. This is potential difference for another capacitor. But if you combine them, meaning add, you should get what? You should get the total initial original potential difference. So delta 1, 2 will be equal to difference. And that's supposed to be now a small number because you're subtracting very close numbers. 1.52 minus 1.50543. So 0.01457 volts. But that is a small number. That's why you need to keep many digits. But now, if you know this voltage, because it has to be, well, the same for C1 and C2. Now you can calculate each charge. Q1 equals C1 times delta V1. Q2, C2 times delta V2. And that will give you the answers.
Okay. That makes sense.
Well, and if you need to calculate the energy, you just pick an equation, plug the numbers, and
Okay.
okay,
Okay, thank you.
sure, you're welcome.